You gotta know a day. Today we're going to talk about the Michelson Morley experiment, named after these two gents right here, Michelson and Morley. They worked at Case Western Reserve University, and they worked with this device here, which is called an interferometer. I'm going to talk more about it later, but that's the big clue that should give you away that it's a Michelson-Morley experiment. So at their time, they knew that light was a wave, and everybody in the physics world thought all waves require a medium, like sound needs air, and you can see waves in water, which is the medium. So it was postulated or thought that there was something called luminiferous aether, which is kind of like this medium that light could travel through. And so they came up with this experiment using the interferometer, which basically shot light at a device that was a half silver disk. So basically half of it got reflected and half of it passed through, and then it bounced back and should have interfered with it, where it was detected by this little interference detector. So if the idea is that after it was bounced back, if it interacted with this ether, that was going to slow down the light, kind of like a swimmer swimming against a current would move a little bit slower, relatively. So if it got slowed down in one of the directions, then it would have, thrown off how the light interfered, and they would have detected that, there was actually this ether that was slowing down the light. To make sure that it was, there was no problems, they put a big stone slab, probably marble or granite, in the basement of the building, and they put it on a pool of mercury, and they moved a little bit. That way they didn't mess up and miss the orientation, because they thought there was, ether was specifically relative to the Earth in a specific orientation. So they put it here, they spun it, so that it should have detected this change when it lined up with the luminiferous ether. However, they did not detect any changes. They really thought that the fringes on the interferometer, kind of the lines here, would change. There'd be a change in how the light interacted, and it wasn't there. So it's called the most famous failed experiment, because it kind of threw out the thought that this ether has to be there, which would have slowed down the light. It actually disagreed with someone named Armand Fuseau's experiment, where he looked at light moving through moving water that actually did kind of show a shift or, interacting with ether. But then later, Kennedy Thorndike, they improved the experiment, and they showed that it wasn't just, remember he had the spinny disk to make sure that it lined up with the ether. Well, they showed that not only did the spinny disk, it didn't matter the orientation of the device, but it didn't matter the speed of the device either, because they shortened one of the sides. And so the speed, the velocity of the wave, of the light didn't matter either. Actually, what happened is there was someone named Dayton Miller, and this is usually an early clue. He goofed up, and he thought he saw drift because he saw, that there was actually a change in light in his experiments. But he just screwed up in analyzing the data, and it was not statistically significant. So what he saw was just an artifact. It's not actually true. And the Michelson-Morley experiment actually agrees with the theory of special relativity put forth by this dude, that the speed of light is actually constant. So it is not affected by this ether that doesn't exist, according to their experiment.